Well, welcome back. I just got done graphing in the transformation of a secant function. Now let's look at cosecant. All right, cosecant. And what we're going to do is we're going to graph this and we're going to identify the period of this transformed cosecant function. Now, if you recall, the cosecant function, if you take the regular one, comes to us as a reciprocal of the sine function, So if you think about sine normally starts here at 0, 0. So we know that whenever we have a 0 for the sine function, okay, that means we're going to have a vertical asymptote, all right, for the cosecant function. And so right here, then we go to pi over 2, which will be 1. That point right there. And then that's going to be pi over 2, 1. Then we go over here, pi. Well, once again, pi, 1 over sine of pi is going to be 0, so the vertical asymptote. And then we come over here at 3 pi over 2. 3 pi over 2 is negative 1, so we're going to have a negative 1 right there. And then right here at 2 pi, it's going to be normally 0, but once again, can't divide by 0, so we have one like that. So we go up like this, whoop, whoop, and then down right here, whoop, whoop. All right, and then we keeps on going onward and forward, all right, in a repeating fashion as we go along this route. Okay, and so the question is, what happens to this new cosecant? Well, we know the period of the old one, okay, is going to be 2 pi, because that's when it repeats. Every 2 pi, all right? Every 2 pi, it will repeat, just like the sine function. That's going to be its period. Now, for this one, it's might have changed. So let's look at what's happening here. Well, if you look at this, it appears that none of the y values, none of the outside is changing. So these values right here, the y, all right, are all going to stay the same. So that means it's going to be, the ranges will stay the same. So from 1, OY value is greater than 1, OY is less than equal to negative 1. Those will stay the same. However, you can see inside the domain changes. And so how does that change? Well, right here we have pi minus x. And so normally what I do in order to figure out how this changes my original values, I take my pi minus x and I set it equal to x sub 0. X sub 0, just so you know, x sub 0, that's like x sub 0 right there. X sub 0 is my original x values, all right, for my original graph. So original x values. So when you see that, all right, original x values. So now I'm going to solve for x. So how does this change? Well, I see that I'm going to subtract pi to this side. Okay, so when I do that, I'll have negative x equals, oops, x sub 0, all right, minus pi. So you're thinking, oh, it's going to move to the left pi. Well, wait. We then are going to divide by negative x, or negative 1, that is. Divide by negative 1. So now we have negative. We have to distribute that through. So negative of the original plus pi. Oh, so what is actually happening here? It appears moving everything to the right pi units. And we're also, with this negative, we're reflecting it. Now, if you saw reflection over, okay, so over the, not the x-axis, is going to be over the y-axis, here. Okay, so anything inside, any negative x to the x coefficient, that's reflection over the y-axis. Okay, reflection of the y-axis generally. All right, so we have this. All right, so let's see what happens here. So all my y values are going to stay the same. So I'll have a, if I start here at 0, so normally I would start here at 0 for my original. So let's see what happens there. I put in 0 here, I get pi. So I just shift it over to the pi units, and then I'm going to have a vertical asymptote. Okay, vertical asymptote. So I'm going to just draw that in right away. It's going to be a new graph. I'm going to make it green. Okay, and so right here, I'm going to have a vertical asymptote right there. Next thing is right there. So I'm looking at this for my new values. I have my next value, which is pi over 2. Well, pi over 2 normally is 1. All right, so I'm going to put 1 right there. Now for this pi over 2, when I plug this in here, it's going to be negative pi over 2 plus pi, which gives me pi over 2. Okay, pi over 2. All right, so I have this pi over 2 right there. All right, just make sure I think about this right. Yeah, pi over 2. And so we're going to have pi over 2, which is right there. And that's going to be equal 1. Get that? All right. And then we'll go to our next one, and next one's going to be pi. Okay, so right here we have negative pi plus pi, and that's going to give me 0. Oh, so I'm actually just going to 0. Oh, this is kind of different. All right, and so right here, oops, that's why I said, so here, sorry, here, pi. Gotta shift this over. All right, so we have this right there. It's going to be pi. So it's just a pi. I apologize. I'll move this. If you were looking at me going, what are you doing? Got some chalk? All right. I'm sorry. Okay, so we have that right there. Now that's going to be at 0. So oops, change this. I don't like those head ones. So we go like that. Very good. So it's 0. And then what's happening right here? All right, 3 pi over 2. Well, oh, this is going to be interesting. All right, so 3 pi over 2. All right, it's going to be negative plus the pi. Okay, if we have that, it's going to give me negative pi over 2. So everybody over here, negative pi over 2. All right, so I get 0 pi over 2 pi. It's going to be negative pi over 2. You can kind of see a pattern right here. This is going to be my negative 1. And finally, I guess I can guess what this last one's going to be. So we plug in 2 pi, which is right there. 2 pi, negative pi, it's going to be negative 2 pi plus pi. That's going to give me negative pi. That's going to have my vertical asymptote, the last one. So right there, all right, negative pi. La, 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 la. And so what we have is, yes, it was reflected over the y-axis, and that makes a lot of sense. Okay, and you can see that this is all just kind of flipped. All right, maybe say like, well, it's been flipped, but it doesn't really seem like it really changed anything. Well, that also makes sense because we flipped this, so we moved it to the right pi. So if you think about this, I'm taking this point right here, I'm moving it to the right pi unit. So if I took that right there, it would be like right there. But now I'm shifting it and flipping it over in basically the same manner as it was right there. So essentially, we're flipping it. Okay, well, we're flipping it first. It'll be right here. And then we're shifting over pi units. So half a pi there, and we're basically starting in the same spot. Okay, and so we have our same thing, just starting in a different direction, but that's what we have there. And so a little confusing, but makes sense, all right, because we shifted it over, reflected it first, because we always go negative first, so we reflected it, and then shifted it, and we ended up in the same place, okay, for all of our different values. Neat. Nice. Okay, so essentially this graph looks the same as a secant graph, but there is some transformations that are involved. All right. What is our period? Well, if we take this right here, our period is our b value. Well, we don't have a negative period, so that's just going to be, you can see that's just going to be 2 pi. All right, nothing changed. All right, because our b value is 1. Okay, and we have that. All right, which is just 2 pi, and that's our period. So our period repeats every 2 pi, the same as before. All right. Well, I hope this helps you out in identifying transformations. I'll go through another one in my next videos. All right. Good luck. God bless.